second part of graphing sine and cosine is on amplitude and vertical shifts. So we looked at phase shift yesterday, which was at left and right. Today we're going to look at two transformations, okay? Both of the verticals. So we'll talk about how to shift up and down and how to stretch up and down. So the first thing I just kind of want to explain is what that word means, okay? Amplitude. And I think the easiest way to explain it is to draw a sketch. So an amplitude, or the amplitude, measures the height of the wave. Whether it's a sine wave or a cosine wave, that part doesn't really matter. Okay, but it just measures the distance from the center line. Imagine drawing a wave and putting a line right through the center. Measures distance from the center line to the highest point, which should be symmetrical from the center line to the lowest point. Should be the same. Now, since the amplitude is measuring a height, what kind of number do you think amplitude will always be? It's always going to be a positive number. Okay, there is no such thing as a negative amplitude because height is a distance and you don't have negative distance. So, just like we did yesterday, first thing we're going to look at is when you have an equation, how do you know if it's an amplitude change? Oh, let me show you a couple examples of problems. That's an amplitude change. That's an amplitude change. And the difference from yesterday is, first of all, you're not doing something inside the parentheses. Today we're doing something outside. We're also not doing adding or subtracting. What operation is happening between the 1/2 and the sine? Yeah? Multiplication. Multiplying. Okay, so today we're going to look at, for the first one, we're going to look at multiplying outside the parentheses. So for this one, the what are you doing? You are multiplying. Where are you doing it? Outside the parentheses. Here's a few examples of amplitude changes. Y equals 3 sine x. Negative 2 cosine x. There's actually a little something extra happening there. Okay, this 2 is an amplitude change, but this negative also causes something else to happen. We'll take a look at what the negative does. And then 1/2 sine x is an amplitude change. Some of these examples up here would cause the graph to stretch, get taller. Some of them would cause it to get compressed or get shorter. Anybody have a guess what that negative would do? Whenever you have a negative, it does one extra thing to the graph. Yep.
Doesn't it flip it?
Yep, a negative will cause it to flip. So if you had something like this, and you just put a negative in front of that, it would look like this. It would flip it. Now, if I were to graph sine x versus 3 sine x, do you think the 3 is going to make it taller? Or do you think the 3 is going to compress it and make it shorter? Yeah.
It's going to make it taller.
Yeah, it's going to make it taller. So yesterday when I asked you the same kind of question about phase shift, it was the opposite of what you thought. I said, which way do you think plus is going to move it? People thought to the right. And it ended up moving to the left. So it was kind of backwards. Today, it's not backwards. Okay, if you put in sine, and then you put in 3 sine, okay, there's the original. It goes between 1 and negative 1. But when you put in 3 sine, it's going to go between 3 and negative 3. Still crosses the x-axis at all the same points, but it just takes the graph and stretches it taller. What do you think kind of like the dividing line is between putting a number in front that makes it taller and putting a number in front that would squish it. What kind of numbers do you think make it taller? 3 obviously made it taller. Would 2 make it taller? Yep.
Positive numbers?
Or
numbers above 1?
Numbers above 1. Yep. Anything above 1 will cause it to get taller. Anything between, that's a fraction, between like 0 and 1, 0.5, 1/3, 1/4. Those would cause it to compress. And then a negative, that causes an extra thing to happen. That's a flip. All right, so you will have some problems on the test that are not graphing. All they're going to ask you is, here's an equation. Tell me what the amplitude is. The amplitude is always the absolute value of the number in front. So let's actually just take some of these and find the amplitude. So remember, A is whatever the number is in front, and absolute value means you make it positive. So what would be the amplitude? We already did it, but what's the amplitude of 3 sine x? Yeah, 3. It's the distance that it goes from the center to the highest point. That's a distance of 3. You don't even have to graph it to figure that out. Just the absolute value of the number in front. How about the amplitude of the second one? Yep.
2.
Yep, that would be 2. How about the amplitude of the third one? Yeah. 1/2. 1/2. What if I did this? What's the amplitude now? Still 1/2. Yep. Still 1/2. What if I did? What if I did that? Still 1/2. That's a phase shift. We talked about that yesterday. But shifting something left or right has nothing to do with how tall it is, right? So if you have multiple numbers in the problem, just focus on the absolute value of the number in front. Okay? And that's the amplitude. So 2 things can happen with amplitude. Basically, I already summarized it. If the absolute value of the number in front is greater than 1, it'll stretch it. If you put in a 5, that'll stretch it. 7 will stretch it. -8, that will still stretch it. The negative will flip it, but it's going to do both. It's going to stretch and flip. If you put in a number that has an absolute value of less than 1, it will compress it. 1/2, 1/3, 0.6. -1/4. Okay? Any number like that will cause it to compress. And we are stretching and compressing on the y-axis. So let's take this graph. Look at that. And let's compare 2 points, one on the original and one on the stretch one. There's a point on the original. There's the same point when you stretch it. Think of these points as having coordinates. What part of the coordinate changes when you go from this point to this point? The x or the y? Yep. The y. The x is staying exactly the same. It's like it's over 1 tick mark. They're both over 1. But the difference is the height. This is up 1, this is up 3. So today, when we do vertical transformations, it's the y value that's going to change. What's nice about the y value changing? You don't have to worry about the x's. The x's have the 0, the pi over 2, the pi. We don't have to change any of those today. So every single x value, I can tell you the answer for every problem in the homework right now. The x values for every problem today are 0, pi over 2, pi, 3 pi over 2, and 2 pi. Every problem. We don't have to change any x's. That's what I just said to you. the x's stay the same. So where did I get those numbers that I just said? Pi over 2, pi, and all that? Those came from the original table I gave you yesterday. And both sine and cosine have the same original x values. They have different y values, but they have the same original x's. All right, so the x's are going to stay the same, and that means the y's are the ones that are going to change. How do we find the new y values? All right, so how do you find the new y values? Very, very simple. All you have to do is take the old y values and multiply them by a, not the absolute value of a. Just multiply the old y values by whatever the number is in front. Because remember, a is the number that's in front. So you use the number exactly the way they give it to you. If it's a negative, use the negative when you're doing the graph, because the negative causes a flip. You wouldn't want to just ignore that negative. It makes a difference when you're graphing it. It doesn't make a difference when you're finding the amplitude. That's a different question. If I ask you to find the amplitude, then yes, you take the absolute value because amplitude is always a positive number. But if I ask you to graph it, you use the value just the way it is. So the arithmetic here is going to be very easy. Remember, the old y values are either 1s, 0s, or negative 1s. So all you have to do is multiply one of those numbers by another number. And multiplying by 1, 0, and negative 1, pretty simple arithmetic. All right, so let's try an example. All right, so y equals 3 cosine x. Okay, so first of all, can somebody tell me what arithmetic operation is in this problem? Yep, this is multiplication. Anytime you do multiplication, it is a stretch. Now we need to be a little bit more specific about where the multiplication is. Is it inside the parentheses or outside? Yeah.
Outside.
It's outside. So the fact that it's outside tells me it's vertical, and the fact that it's multiplication tells me it's a stretch. This is a vertical stretch. If you multiply inside, well, we'll see that tomorrow. Okay, but multiplying outside, vertical stretch. How about Yadiel? What stays the same when you stretch something vertically?
What?
The x's. Yep. So x's are going to stay the same. Can someone remind me, what are my x values? Yep.
0, 5 or 2, 3, 5 or 2, 2,
2 pi. All right. So we've got that. Now, off to the side, put a box around this. That's where your answers are going to go. Off to the side, let's put our original y values and leave some room to do a calculation, and then we'll put the answer in the box. Andrew, do you remember what my original y values are for cosine?
1, 0, negative 1, 0, 1.
Yep. And what are we going to multiply all these y values by?
3.
3. Multiply them all by 3, and those are our new y values. 3, 0, negative 3, 0, and 3. Okay. Question on the table. Okay. So, let me draw the sketch. What I'm going to do for every graph is I'm always going to change my scale. Because if you scaled something, like 3 is not bad, but let's say you scaled something by 30. Well, I don't want to have to draw it 30 times as big. That's going to be too big of a graph. So what you can do is instead of going by ones on the y-axis, let's scale the tick marks to go by threes. And then it technically will look the same size as every other graph we're doing, but it's because we changed the scale. All right. And then these we can label. And plot your points. 3, 0, negative 3, 0, 3. Make your sketch. And that's the graph of 3 cosine x. Now, if I had to do, say, 5 cosine x, I could use that same picture. All I have to do is this. Now, by changing those to 5s, that's the graph of 5 cosine x. So what's going to happen is all my graphs today are going to look the same because I'm going to be changing my scale instead. So I don't have to draw it huge. Okay, any questions on that idea? Okay. So that's the first one. That would be what we call a stretch. Now we're going to look at one that would be a compression because the number in front is less than 1. Okay, so same type of problem. You're multiplying, and it's outside the parentheses. Even if you didn't put parentheses here, that doesn't change the problem at all. Basically, you're multiplying, and it's not next to the x. So if you don't see parentheses, think of it that way. Is it next to the x? And the answer here is no. Okay, multiplication out in front, that's a vertical stretch or compression. Tyler, what values did we just say stay the same when you stretch vertically?
The x values.
Yep, so we can write those down. And by the end of today, hopefully, you start to remember what those are. And now, Cameron, what are my original y values for sine?
B1, 0, negative 1, 0, 1.
Okay, those would be for cosine. So if we had 1/2 cosine x here, then what you just said would be correct.
0, negative 1, 0, 1, 0.
Let's just sketch sine quick. So sine looks like this. So you start at 0, and what's your next one?
1,
1. And then
0,
0, yep,
negative 1, 0.
and back to 0. Okay, and Megan, what am I going to multiply all those by?
1/2.
Yeah, take half of all of them. So you could do times a half, or you could really just say divide by 2. That's the same thing. And Anthony, when I do that, what do I get for my new y values?
0, half.
Yep.
0, negative half, and 0.
Yeah. And actually, I could just use that picture right there. If I just labeled this as a half, and then I labeled that as negative a half, and then put in my x's. Because the picture for sine is going to look like that every time. All you have to do is put the right labels on the axes to make it fit your problem. So I want negative a half to a half, and then I want 0, pi over 2, pi, 3 pi over 2, 2 pi. Any questions on that one? All right, so let's look at this one. Forget the graph for a second, but just let me ask a different question. What's the amplitude of that graph? There you go. 1. So technically it's not an amplitude change. But the calculations you're going to do to make the new table are exactly the same type of calculations you would do if it was an amplitude change. So what's really happening here? If it's not an amplitude change, what is that negative going to do? Yeah.
Okay.
Flip it. And technically, if you wanted to imagine what number was in front here, what number is in front of cosine, even though it's not written? Yeah. It's like a -1, right? That's what you really have. So you are multiplying by a number in front. It's just not a number that's going to stretch or compress it. It's just a number that's going to flip it. So we've got the same x values. How about, Abigail, can you remind me, what are my x values again?
0, pi over 2, pi, 3 pi over 2, 2 pi.
All right, and y values? Well, put the originals off to the side. 1, 0, -1, 0, 1. And Julia, what are we going to multiply them all by?
1.
Well, if we multiplied them by 1, they would stay the same, and then nothing would happen.
-1.
Multiply by -1. Okay, so we're going to multiply them all by -1. And there's your table. Okay, questions on the table? All right, so let's make our sketch. So that'll be 1, -1, 0, pi over 2, pi, 3 pi over 2, 2 pi, and plot your points. So -1, 0, 1. So -1, 0, 1, 0, -1. So instead of being, if you think of the wave, instead of being this part of the wave where it dips down, it's now the part of the wave where it goes up because we flipped it. So that should look kind of like that. And this would continue on. Okay, any questions on that? Right, so that's the amplitude change. Okay, so pretty straightforward. And what do you think the difference in sound would be? It's not super interesting, but if you played a sound like the red one compared to the blue one, when you hear it, what do you think the difference would be? Yeah?
Would be a higher pitch.
Okay, so that's one thing that could change. It could be a higher pitch. What's another thing you could change with the way somebody hears a sound, besides the pitch of it? Yep.
The volume.
You could change the volume. So it is going to change one of those two things. We can just try it real quick. So last transformation we're going to look at for today is a vertical shift. Vertical shift doesn't really have any direct connection with sound that I can explain, that I'm aware of. But think about what arithmetic operation we did yesterday when we did a shift. Did shifting involve adding or subtracting, or did it involve multiplying? Which one of those was involved yesterday? The add, subtract, or was it more of a multiply? Yep. Add, subtract. Adding and subtracting is always a shift. Yesterday, we did adding and subtracting inside the parentheses, and it moved it left and right. Where do you think we're going to do the adding and subtracting today? Yep.
Outside.
Outside. So if you have a problem, and you add or subtract something outside the parentheses, okay, that's a vertical shift. Even if you don't put parentheses here, that still technically is a vertical shift. The only way it can be a phase shift is if you put parentheses around the variable and the number you're shifting by. That's the only way you can make it a problem like we did yesterday. So this is a shift. We'll see if it's up 2 or down 2 in a second. This is a shift by 3. It's either up or down. What do you think the plus 2 would do? Do you think it would shift it up 2 or down 2? Yep. No, it will shift it up 2. So if I put in sine of x and then sine of x plus 2, I had to be careful. I closed the parenthesis so that plus 2 is on the end. If I hit graph, you'll see the original in blue, and then you'll see the new one in red. And the red one is going to move up 2. Now, if there were parentheses around the x and the 2, so if there were parentheses like this, and then carry it out, that would be a phase shift. Because now you're adding 2 to the x value, because it's in parentheses. That would move it left 2 units, compared to this moving it up 2 units. Questions on the difference between shifting left and right compared to what we're doing now, up and down? Okay. So the 2 transformations we looked at today, pretty much common sense in terms of what direction you think it would move. You would hope that if you add something, it would go up and subtract would go down. That makes sense, and that's what happens. So in other words, don't do the opposite. And yesterday we did the opposite, today we're not. So vertical shift moves up if you add, and it moves down if you subtract. So I'm going to bring that graph back up that we just did on the calculator, and I want to look at 2 corresponding points, and I want to see if we can figure out what's changing this time. Is it the x or is it the y? There we go. Okay, so here's 2 corresponding points. One here, one here. What's changing in those 2 points? Is it the x value that changed or the y value? Cameron?
The y value.
Yep, it's the y value again. Because if you take the blue graph and you just shift it up 2, everything moves in a vertical line. That means it's not moving left and right. If it's not moving left and right, the x's stay the same. So we can copy down the x's from the original table. So again, 0, pi over 2, pi, 3 pi over 2, and 2 pi. Those are going to be our x's for every problem. Now, how do we find the new y values? Well, the calculation is really going to be just as easy as it was for the last transformation. First, look at what's been added or subtracted. Okay, I just called it d. So d is the value that's been added, or it could be subtracted if you're shifting down. All you have to do is take that value, and if it's positive, you're going to add that value to all the originals. If it's negative, you're going to subtract that value from all the original values. And you don't do the opposite. If you see a positive, like a +3, you need to do a +3 to all your y's. If you see a -5 on the end, you need to do a -5 to all your y's. Don't do the opposite. Don't know how to make that any clearer, but sometimes people do the opposite. You can have a reference sheet, so I would put it on your reference sheet. Don't do the opposite for a vertical shift. visual? There you go. Don't do the opposite. All right, so let's try 2 examples of a vertical shift, and that'll be it. So sine of x plus 2. Actually, I just did this one on the calculator, so you already know what it's going to look like. So first of all, it's addition. Second of all, it is not in parentheses with the x. Addition makes it a shift. Not being in parentheses with the x makes it a vertical shift. All right. So Desiree, vertical shift, what column stays the same?
X.
Yep. So we're going to write down our x's. Okay, got those. Now I need my original y's. Isabella, what are my y values for the original sine function?
1, 0, -1, 0, 1.
All right, keep those in mind when we do the next one. We're going to use those for that. Anyone else remember what are my y values for sine? Yep.
0, 1, 0, -1, 0.
Yep. So 0, 1, 0, -1, 0. And what am I going to do, Connor, what am I going to do to all those y values? Add 2. So can you tell me what my new y values will be?
2, 3, 2, 1, and 2.
Yep, 2, 3, 2, 1, 2. That's it. Questions on the 2? All right, now let's make our sketch. So I only have to go up to 3. That's the highest y value that I have. So I would just take 0 to 3. That works fine. If I had to go up to 10, maybe I would scale it by 5s or something like that. It's okay to put your labels pretty close to the lines because I know I'm not drawing in quadrant 4. My sketch is going to be shifted up into quadrant 1. So I've got 2, 3, 2, 1, and back to 2. Okay. What's the amplitude of that graph? Yeah?
1.
Yes, 1. Sometimes people say 3. 3 would be the highest value it hits, but the amplitude is 1. Imagine putting a line right in the center and measure the distance from the center to the highest point. It is 1. Yep. Questions on that one? All right, so let's try this one. All right. TJ, can you tell me what kind of transformation that is? Because we've studied 3 of them now, and how you know that.
Obviously, there's the subtraction and inside the parentheses, so wouldn't it be a...
Can you say that again? You said it's subtraction, and where is the subtraction?
outside of the parentheses?
Yep, it is subtraction outside of parentheses. So that makes this a what kind of problem?
Wouldn't it be a horizontal?
So horizontal is when you add or subtract inside parentheses.
Oh, okay, that's right. So there's only one other vertical.
Yep, vertical. There's 2 that are vertical. Help them out. What kind of transformation is this one? A vertical? Yep. shift. This is not a stretch. Stretch would be multiplying by a number in front. This is subtracting, so that makes it a shift. Okay, original x values. How about, Ryan, can you tell me my original x's?
0, pi over 2, pi, 3 over 2, no, 3 pi over 2, and 2 pi.
2 pi. And Isabella, what are my y values for cosine?
1, 0, negative 1, 0.
Yeah. So that's where we want to use those. And Lucas, what am I going to do to all these y values?
You're gonna take the cosine of x and 5.
So here we're just going to do some arithmetic. We don't have to do any trig with cosine because the cosine is kind of built into the original table. So the fact that we wrote down 1, 0, negative 1, 0, 1 takes care of the cosine part of the problem. We just have to modify all these values by doing what to them? Just subtract 5. Okay, and how about Annika, if I subtract 5 from all of those, what do I get?
Negative 4, negative 5, negative 6, negative 5,
There you go. So there's your table. And lastly, we just need our sketch. So we've got 0. I think the lowest we have to go is negative 6. Yep, got enough. Let me make this so I can see it. That's better. Okay, and I got to put my labels for my x's. 0. This time I'm going to put my labels up above the grid just because it's, I think it's easier to see this time. And plot your points. So 0, negative 4. Pi over 2, negative 5. Pi, we're at negative 6. Negative 5, negative 4. And there's your sketch. Just like that. Okay, questions on it? All right, so we've looked at 3 out of 4 of the transformations. We've done phase shift, left and right shifting, vertical shift, it's up and down, and we've done vertical stretch. So the last one we have to look at tomorrow is a horizontal stretch. So we'll finish that up tomorrow, and then Thursday will be a review day. Worksheet is online, so same deal as last night, just print it, or do it on blank paper, or if you want to do it on your Chromebook and just show me that, you can do that too. Does anybody have any questions about where to find the worksheet? Yes? I do. Any questions on where to find it? Oh.